Thank you all for coming to this latest installment in our ongoing seminar series. Today it is about quantum arts and culture, the fusion of science and creativity. So we're going to be exploring today are all of the fascinating ways that quantum concepts influence the arts, from quantum-inspired music and visual arts to the philosophical implications of quantum theory on culture. So just a little bit of background about this seminar series. The American Physical Society, APS, in partnership with the Johns Hopkins Science Diplomacy Hub, welcomes you to an innovative international event dedicated to advancing global collaboration and understanding in quantum science and technology. This is one of several worldwide initiatives to celebrate 2025 as the International Year of Quantum Science and Technology. Our experience helps connect scientific communities, industry leaders, policymakers, national labs, and the public, fostering discussions on the transformative impact of quantum technologies. All the previous webinars from this series can be found on the APS YouTube channel. Today, we have our latest Quantum Connect webinar in the series, and we have 5 speakers. Today, we have Roger Malina, Camille Stavrakas, Liuxuan Zhang, Nicola Triscott, and Kamalagharan. So what we're going to start with is we're going to have each one of our speakers introduce themselves and tell us a little bit about how their passion and their career connects to the quantum industry. Then we will launch into some predetermined questions, kind of guiding the discussion for a while. And then on the hour, at about noon Eastern, we will switch to any questions that have come in from the audience. We will finish at about 12:15 Eastern. Let's go ahead and get started. So I'm not going to call on anybody. You're all welcome to interact with questions as you care to. You do not have to answer every single one. But we're going to start with having every one of you introduce yourself and tell us a little bit about your background and how it connects to the quantum industry.
Who should begin?
Go ahead.
Okay, my name is Lucy Liuxuan Zhang. I'm a faculty assistant at QUICS, which stands for the Joint Center for Quantum Information and Computer Science at the University of Maryland. Besides being a mathematical physicist and founding and running multiple math and academic enrichment programs for gifted elementary and middle schoolers for the recent years, I've always loved to share and to give via the performing arts as a violinist and as a singer. At University of Maryland, I have led 2 projects which explore the intersection of quantum and music. Specifically, I chose to use musical improvisation to depict quantum concepts and to add a new dimension to scientific presentations or to a co-created scientific narrative. Yeah, so I think maybe that's a nutshell in what I do. Yeah, thanks.
Thank you.
Okay, I'll jump in since everybody's being polite. So my name is Roger F. Malina. I started my professional career in astrophysics, building telescopes, but I just want to emphasize that astronomers do not meddle in the world. Yes, we use quantum mechanics, and quantum physicists are meddlers. They conduct experiments. But we understand, we build telescopes because we don't realize how the human senses were not designed to understand what's bigger or smaller than us until very recently. And then, because my father died, I moved to publishing the journal Leonardo, which published the work of meddling artists, scientists, and engineers that collaborate together to express themselves. But now I'm leading in Texas, of all places, quack, quack. I'm leading a lab that studies emergent phenomena. And one of the things that we noticed in complex systems is when I publish something today, the majority, over 75% of the audience, is not humans, it's AI. So we're trying to figure out how to express yourself differently for an audience of AI beings. Thank you.
Shall I go? Hi, I'm Nicola Triscott. I'm the Chief Executive of FACT, which is a major screen and digital art centre in Liverpool in the UK, where we create groundbreaking digital and immersive art that critically engages with technology's impact in society. So I previously founded and led the organisation Arts Catalyst, which specialised in commissioning art science projects. I ran that for 25 years. Commissioning many artist projects, curating exhibitions, organising conferences, publishing books, including the publication The Live Creature and Ethereal Things, which explores connections between art, physics and culture. And it's a theme that's also close to FACT's heart, as the organisation partnered with the Arts at CERN programme for many years, which resulted in the international touring exhibition Broken Symmetries. So I guess I'm interested in the politics of representation around technology and artistic versus scientific methodologies. And I know I can't show anything visual on this webinar, which is a frustration, but I'm gonna put a link to just the trailer for Broken Symmetries in the chat if I can. And then I'll try and pop some images in there. It's difficult to talk about art without images for me.
Perfect. Yeah, thank you.
Go ahead. Yeah.
Go ahead.
Hey everyone. My name's Camille. My background is so I'm a physicist by training. I started as a theoretical physicist and then moved to experimental quantum optics, worked on the effects in diamond and all sorts of atomic systems. In parallel to that, always had an interest for arts, mostly centered initially on music, but then that evolved to other performing arts and currently circus arts. That led me to create a network of artists around me and work with musicians and circus artists on different projects. That led to a quantum circus performance that we prepared for the Global Physics Summit that took place in Anaheim in March. Other than that, I'm currently an R&D engineer at PsiQuantum, which is a company that whose mission is to try and build a photonics-based quantum computer. So yeah, that's my day job and then other projects on the side.
Amazing. I'll go next then. So I'm Ilar Kamalagharan. I guess first and foremost, I'm an artist, producer, vocalist primarily. And I actually went and studied physics and philosophy as my undergraduate degree. Was just really drawn to it. But being a musician and writer kind of happened alongside it, literally. So the first summer holiday, I went on a world tour as a guitarist with an artist called Imogen Heap. And from there, I met lots of other amazing musicians who were also at that intersection of music and technology, and realized that both can happen simultaneously. So those were my concurrent realities, so to speak. So from that, I kind of mainly went into music. I founded two choirs, Trans Voices and Contemporary Voices, both based in the UK. With my more recent practice, since kind of quantum computers becoming more accessible, I wasn't only able to talk about quantum in metaphorical sense, but also was able to use it a little bit more directly in various collaborations that have happened more recently, including an exhibition my first installation piece at the Barbican in London, which was in partnership with Trans Voices and Monon. It's a spatial audio piece, and also used applications made by Moth Quantum, which we've kind of worked together on as part of an artistic incubator project. And then since then, we've also released a piece of music which is an infinite mix that just continuously generates, and that's using quantum reservoir computing, and that is available to listen to forevermore as long as the internet exists. So in a nutshell, I think that's probably a good place to leave it.
That's wonderful. Yeah, thank you so much, everybody. So we're going to start into the questions that we have prepared for you. And the first one that we have here, some of you have touched a little bit on this already in the introductions that you've given. But for anyone who wants to answer it, what was your kind of quantum moment, an experience that kind of first sparked your interest in quantum technologies and kind of set you on your current career path?
Okay, I'll jump in. So first, I'm going to appeal to a quantum creature. Since we can't see her, her name is Annick Bureau. She's signed up for this. We set up the Leonardo Observatory of the Arts and Technosciences in Paris, and we just started wasting our time with artists, and I was a scientist. And then she started this, I don't know, strange habit. It was called the Rendezvous de la Pentecost, and we would go nowhere, somewhere we didn't know where we were going, and there was no agenda. And somehow, strange particles of thought emerged from the discussion. And I then went on to become a scientist that had ideas that only came from the neurons of artists. And then I'm going to mention another emergent creature on this call. His name is Taylor Hinchcliffe. He's the director of research in our lab. And he got a first degree in biochemistry, I think it was. But then in the study of emergence, he published a paper on the emergence of sepsis in the human autoimmune system. So for some reason, the complex system of the autoimmune system suddenly lets germs in and people die. And that's all quantum mechanics at work. Thank you. Oh no, I have another one. When I was a PhD student at UC Berkeley, I worked to make invisible light to visible light, the extreme ultraviolet to images of the sky. Well, yeah, the human senses are badly designed to understand who we are and where we are. Thank you. That was it.
I don't mind going next. So as a child, I was always just taking things apart. So my approach to music was much the frustration, I think, of my parents would be to deconstruct the instrument completely, because I wanted to kind of understand how it worked and why it made the sound it did, and wanted to somehow get inside it. And I think my interest in sort of emerging technologies, I'm not even talking about technology, I suppose, just quantum more as an idea, prior to the interest, really was around human nature, around consciousness, and whether it really exists, whether it doesn't, whether our idea of it is the right one or the wrong one, or what. And then, you know, as I got kind of into computing and using computers to make music, the usual kind of thoughts, existential crisis of teenage years hit. And I was very drawn to just the kind of sci-fi, I think, around AI and the future and consciousness and patterns of thought and things like that. those kinds of questions. And those, I think, are probably the precursors to what led me to want to go and study physics and philosophy, to be able to kind of develop the skills to deconstruct things and to understand all those things that Roger described that we can't see or experience with our limited senses. And then I think as I started to study physics and philosophy, I think the thing that really struck me was the limits to our knowledge and what we possibly can't ever know or is unknowable, or and then deeper still the philosophical implications of quantum. And although at that time the first experimental quantum computer had been built, it wasn't something that we could use or access to do anything at all, really, let alone make music. But the thought had been sparked that one day this would be a possibility. So I'm really excited that I'm able to do something in that field now. And I think I'd also say that the other interest that I had in quantum, still having quantum this that I just find deeply fascinating, is kind of from the perspective of like polarization and reductive thinking, that quantum in many ways goes beyond binary sort of existences, and so in a world that can be very stuck in black and white debates, I think thing that we can take from quantum in terms of the power of nuance, plurality, and coexistence, and concurrent realities, that kind of an idea. So yeah, I'm interested in it in many ways. The woo-woo aspect of it, as well as the nuts and bolts of how it works and what it all means.
Maybe I could say a little bit something. So I started my research career as in astrophysics as undergrad. I mean, actually, high school student. And then at some point, I wanted to branch out in my undergrad, and I took this class in. I said, okay, maybe quantum is something that's interesting to do at that moment in time. That was a while back, and I took this quantum information theory grad course as an undergrad with at University of Toronto, and with Professor Hoi Kwong Lo. And he works on cryptography himself, but actually in that course we get to choose from a variety of projects, like for our course project, just to read up on the paper and to write about our understanding about it. It's not real research project per se, but there were so many cool topics, like I had to choose between there are other ones, but the short list was like the toric code, the adiabatic quantum computation, and cluster state or one-way quantum computation. So I ended up choosing the toric code for that project, and read the Preskill and Kitev and Landau paper, and and so that was fun. But then got me started. So but also for my master's, I actually did picked up on like kind of the cluster state perspective. So that was done too. Also, the first exposure probably from that project list that I got from the course. And then so my during my PhD, I explored Kitev's quantum double model, which is some sort of generalization of the toric code and so on. So that was like, it was, so the quantum moment, I guess, would be like the course project. I mean, from my grad course I took as an undergrad. So I was really thankful for the exposure and the good list of topics that Professor Hoi Kwong Lo put together.
Okay, I will try to go after that. So for me, I would say, as with most things in my life, I don't know if there is really a moment where all my attention gets fixated on one theme or one topic or one goal, and that's what's been also, I guess, confusing to navigate sometimes, but that's opened up to bridging fields and sometimes bringing things like, arts and music and performance and everything together with science. So I think for me it started, I mostly, when I was younger after high school and all that, my first path in higher education was actually in philosophy and literature, and really more interested in the big questions of, that philosophy can raise, and that kind of logic. And then it kind of evolved from there to physics taken as a philosophy of nature. Started with astrophysics, cosmology, and sort of explored from there, from like the larger scale of the universe to wanting to know then what happens at the very small scale, and sort of got focused on quantum at that point. And also there was a curiosity for, all the counterintuitive aspects, or the all this new paradigm that my mind had to try to, get an understanding for, that was different from most all the other like classical mechanics or whatever other topics that were taught before, and also an appeal for the formalism, I think, for me, like the mathematics of it and the linear algebra and something elegant in that. So I would say, it was a journey that led me there, and then that's where I ended up staying. I got to that point roughly when it was time to start grad school and the PhD, and also I was seeing that as a good platform to work on both the theoretical aspects and the experimental aspects. I like the idea of being able to do a bit of both, and that's a field that allows you to do that. So yeah, so that's how it happened for me. And there was never, certainty that that was the field I wanted to stay in. I ended up staying in it, at least for now. We'll see what the future holds, but yeah, that's me.
We can move to the next one then, if we'd like to. Our next question that we have here is, what approaches to quantum communication have you found the most authentic or compelling, either by scientists or by artists?
Shall I jump in? So I think I'm very interested in stories, and I find the most compelling approaches to this subject to be those that recognize that we're always part of the reality that we're investigating, and there's no separation between the observer and the observed, which is an old idea that stems from Niels Bohr and has been picked up and extended by many thinkers. And I think so Karen Barad, who's a feminist physicist and philosopher, example, extended that thinking to develop what she calls agential realism. So this idea, she coined a term interaction to emphasize that subjects and objects don't exist independently and then interact, but they rather emerge together through their mutual participation. And I find that I'm very interested in when scientists or artists or storytellers or writers really understand science, not just as an abstract knowledge, but as a human experiential process, and put that across. And I really think that artists play an invaluable role here, because they help to create that subtle, nuanced, vivid, responsive art of communication that we really need for knowledge to be truly assimilated by society. Artists aren't illustrating quantum physics, they're really just exploring their own fascinations, and in doing so, they create tangible encounters with the remote scales and the mediated data of fundamental physics. So an artist I've worked with, Fiona Crisp, for example, has explored how we might approach the kind of remoteness of fundamental physics, the laboratories where this happens, by kind of being put in a sensory relationship to that endeavor. So we did a project together called Material Sight, when she used non-documentary photography and moving image and sound to build this kind of sense of encounter with the laboratories and the extreme environments where experimental and theoretical physics is performed. So like Bulby Mines or LNGS in Italy or CERN. And by focusing on those material spaces and that kind of overlooked equipment of physics, she reveals that human apparatus that's at the heart of quantum investigation. She kind of makes visible the fact that the knowledge that we have emerges through a very messy, embodied process of doing physics. And I could cite a bunch of other examples, but they're works that don't explain quantum mechanics. They invite us into an experiential relationship with us. They kind of close the gap between that abstract knowledge and that lived experience that can otherwise make physics feel like peculiar rites performed on some sort of altar in a temple, rather than a really vital part of human inquiry into how we co-create knowledge about the universe.
Thank you so much. Does anyone else want to jump in on that?
Sure. So I guess for me, being a performer and not as much of a composer, more of an improviser and a performer of like, also traditional, well, not traditional, like classical music, and also like somebody who likes the abstract mathematical side of quantum, especially topological quantum computation. So I try to bring these two together by improvising music on the concept, but also the narration of a story, the kind of journey, take people through something, and then adding the musical dimension to that. But also, I don't know, there's so many ways, so many different things you can choose to depict any given time. It could be, the scientific content, it could be the emotional content, it could be it could be any combination of things, or what sparked in the moment, maybe the energy in the room. Sometimes you can pick all that up because it's improvised. So for me, using the improvised medium is somehow my language, at least for now. Maybe one day, I think also as the process is evolving, the process of creation and design for these projects is evolving. If my early projects, like, you almost have very little rehearsal time. You just, not as much planning. And now I think the development more in planning, and maybe eventually it will be a more, I'm looking forward to something about like a little more semi-composed, semi-improvised, or something with a bit more structure. So we're just exploring all those directions. Thanks.
And in there, because I think what you were saying about improvisation really spoke to me. And I've often thought that in some sense, when two people improvise together, even when you're improvising with just yourself and an instrument, there's some sense of, I guess, metaphorical entanglement, between those two things. You kind of become one system in a way. And I think, you can kind of explore quite a lot of these ideas through that kind of social and emotional metaphor. And I think that can be really powerful. I'm also always amazed at how readily children, but also artists, can sort of engage with some of the abstract ideas, philosophical ideas that emerge from quantum, much more so than perhaps we would usually suspect. And I think that's really powerful in itself, and it makes me think a lot about access, and it makes me think a lot about how we can make it more possible to bring this incredible, for want of a better word, magic to and mystery to more people. On a practical level, I think this is a fantastic book. by Bob Kirker and Stefano Goggioso, Quantum in Pictures. And if you don't know about it, I think it's great. I think Bob has got a fantastic way of communicating really, really complex ideas. You've got a copy as well. Okay. Yeah, I mean, and what's amazing about it is they've managed to use this book to teach quite complex ideas to really quite young kids, who are sort of like primary school or the first years of secondary education, through just reframing things, using different language, but also diagrammatic thinking, which might suit some people, other people not. But also that's just sort of speaking very much directly in terms of the kind of raw idea of representing quantum using some kind of artistic medium. But I think I also really believe that that doesn't have to be the role of the arts in quantum, or in relation to science. It's not just about communicating scientific ideas. It's actually much wider than that. And what you said, Nicola, really spoke to me on that front. Another book that I would really recommend for people who are interested in music is this one, Quantum Computer Music by Eduardo Randa. There's actually a volume 2 now as well, I believe, but this is really fantastic for anyone who wants to explore on a more practical level what's being done at the moment, and what kind of algorithms are out there, and where you can find them, and sort of fun experiments that people have done so far. But I think much more broadly than that, I really believe in things being sort of broad. Not everything suits everybody, so making things tactile and somatic, using visual experiential learning. I think people do that really well, where you can just enter a space and explore it as you feel compelled to, that naturally differentiate really cleverly across many sectors of society, so people can have an initial feeling walking into a space, and then if they feel compelled to, can dive further into one channel of that. And I'd also say that there are some standout artists. I know Nicola mentioned one of them that I was going to talk about, but also I'd recommend looking at work by Libby Heaney and Conrad Shawcross and people like that as well. That's something that's really inspired me, and people who I think have that at the heart of their work as well. Yeah.
Just want to jump in and say on this book, I actually ran a 1 week Math Plus retreat. It's called Math Plus Retreat, and one of the 3 courses was on this book for the 9 and 10 years olds.
And how they take to it?
Good.
I was so curious.
And so the other courses were bridge, the game of bridge, and then group theory. So they well, some people, they're all joke, they have funny, they're funny, and so well, one remark I remember: spiders have 8 legs, not like random, the spider theorem, still have spiders and everything. And they're complaining that it's not real spiders, and you can circle back in the legs. But they did the proof very well, so they were able to use picture proofs. Well, some kids anyway. So they're a small number of kids, and they. Like 4 kids that were there, a couple of them were doing a lot of proofs, and and they were unzipping using that by algebra laws and so on. So it was great. It was fun.
That's so cool. That's brilliant. And there's also I can't remember at the moment who made them, but I met somebody recently who makes quantum comics as well, and kind of similar approach, but yeah, kind of through characters and through narrative as well. It's really
okay,
cool.
I'm going to jump in on quantum comics. So here in Dallas, I had a wonderful physics student from South Sudan, and she'd been miserable all her teenage life, and she moved to Texas. But there was so much ambient racism, it only increased her anxiety, it didn't decrease it. So she said, I'm going to move back to South Sudan. But then I had her work in a quantum physics lab, and she realized that at the scale of molecules and atoms and electrons, nothing has color. And so she did a comic book where she shrunk herself by powers of 10 and racism disappeared in her life. Talk about expressing anxiety through art. Which gets me to the powers of 10. Yeah, wonderful movie and all that kind of stuff. But the International Bureau of Weights and Measures has recently announced a new scale of 10. We all know a micro, nano, pico. Their new scale that they just announced a few months ago is the YOTA, YOTTA. What? YOTA astronomy? And so periodically, when people are studying things at bigger or smaller scales, they give them names. Well, unfortunately, powers of 10 is only because humans have 10 fingers. What? Well, AI only has 2 fingers, zeros and ones. I think I want octopus scales of 8. So I will only stop there to think about how numerology, zeros and ones, 1 to 10, obviously there's duodecimal that a few stupid people used for a while, but let's go with scales of 8, octo scales. Thank you.
It just prompts me to remember Thomas Saraceno's representations of the universe and the cosmic web through spider webs.
Yeah.
And like the biggest piece where he had like 7,000 spiders working for days to create this extraordinary representation. Powers of 8.
No, but I mean, I just like the political message that let's shrink human beings and we'll eliminate racism and gender.
I love that. I would be so in favor of that.
No, but it was a comic book that captured that idea, and that gets into physics and art and so on.
I think it might also just be nice at that point to mention the art collective Black Quantum Futurism.
Yes.
Who apply these concepts from quantum physics, like the influence of observation on reality, to Black and African cultural traditions of consciousness, time, and energy. And they kind of propose that past and future aren't cut off from the present, but influence who we are at any point in space-time. So their work kind of collapses space-time towards desired futures. I mean, it's such a great thing to be thinking about at the moment, isn't it?
Thank you all for those answers. The next question we have for you is a little bit different. So how has the landscape of quantum technology evolved since you began your career? And what developments have surprised you the most? And in what ways has it affected your kind of life and career journey?
Okay, can try to start on this. I would say, I mean, it's just the speed with which it went from labs to, being taken by startups and companies and being set as a basis for a product and all those developments that followed. And I think to me, it's just, the speed with which it went from lab to actual attempts and concepts that were very, very abstract, like, cluster state computing or all sorts of continuous variable, all sorts of things that were very, very fundamental, just like, a decade ago, and are now being applied and, in devices that aim at being quantum computers. They're not obviously there yet, but it's very bold. Like I find it so bold, just the way that people have taken these concepts and tried to apply them in such a short time scale. In my career, I don't know well, I guess it did make a leap in about a decade. The technology I'm working on from the first lab demonstration to being something that a company is trying to build. So definitely that speed has enabled it. I would say, yeah, to me it's just so many, but if you look at the Nobel Prize this year in physics that was awarded for the tunneling effect, and then that was not so long ago. That was a few decades ago, and it's now in devices at Google and IBM, in Josephson junctions, and it's a huge thing. It's the first macro scale manifestation of quantum physics that we know. So it's really going from something that's hugely impactful and significant on the fundamental level to a device that we're trying to harness and having facing all sorts of challenges that are opening up into other areas and everything, and prompting more research and more development. Yeah, I don't know if that answers the question, but that's kind of my take on it.
I think I've just like I think it's a really funny term, but we have certified randomness apparently achieved this year. So I guess like quantum computing is obviously like as a whole has gone on this sort of as you said, this sort of big journey. And I suppose anything, since I began thinking about using it somehow to make music in some sense, I guess the biggest shift has been that I can actually now do that in some sense, whether that's using simulation or whether that's using real actual quantum hardware. It is actually possible to do that, and there are ways to send code and do and receive results and make them part of a workflow that gets you pretty much where you want to be, to create meaningful work. So that's a huge shift. I think what's really interesting to me is how this sort of like period of acceleration has coincided. On the one hand, like that acceleration has coincided with this other kind of force of like truth no longer meaning anything in politics, and how it's at this point where we're at this sort of the two couldn't be further apart in a way. Science and politics and art, how sort of at odds they seem at the moment. I think that's really in a huge tension. Um, and I guess also just on a practical level, there's just been this huge investment in quantum, certainly in the UK. And with that has also trickled down into more potential for the creation of art and the creation of work that somehow speaks to that or responds to it. And so I think that's interesting. And I think also in the time that I've been making music with quantum, I think I've noticed that there's more of a community now. So there is actually, it's a few of us. There's actually quite a few artists, and there is a body of literature emerging, and there are places to perform that work, and there's just quite an exciting time to have that community, and how that then means that it starts to develop in terms of the cultural identity, and it's started getting me to think a lot more about quantum culture as an idea and what that might become, and the opportunity to shape that, but also the kind of concern around it, and what we collectively want that to be, I think is also really interesting to me. Yeah, sorry, that was a bit of a ramble. I'll leave it there.
Okay, so I'm gonna jump in. So as I mentioned earlier, I'm now involved with Taylor Hinchcliffe and others setting up a research group on the study of emergence in complex systems. The one thing that, of course, we all immediately discussed at the beginning was Maturana and Varela's concept of autopoiesis. And so there in a complex system, change often doesn't happen top down, like in politics, or from the side, like in the legal system, but it just happens in the corner somewhere. And a group of people like this group just start interfering with the whole system. And so that gets back into the question of scale. One of the terms, one of our members, advisors is Patricia Olenek at University of Washington, and she's been part of a group trying to understand the concept of habitability. So let's forget about climate change. What could make our planet more habitable? And it kind of makes you think about different scales. Climate change is happening. That's okay. But habitability includes how groups of people like us could trigger a systematic change in the system, and we'd have educated politicians who make decisions based on not quantum mechanics, but rationality and causality. Oh dear, quantum mechanics would not be useful in politics. But I'm just going to finish this with something that the discussion has made me think about. As Annick knows, when I was living in Marseille in the south of France, we set up an institute for interdisciplinary research, where we invited artists and scientists to work together on projects. One of them was Rachel Mayeri, who was the first artist to make movies for orangutans and other primates than humans. And surprise, surprise, discovered what the scientists didn't know, that monkeys would watch humans killing each other and having sex, and humans would watch monkeys killing each other and having sex. And then the next project that emerged out of that was we set up an ecological observatory on the mountains in the south of France, where on one hillside we left it as it was with the plants dying because of climate change. And on the other hillside we put a huge netting that reduced the rainfall by 30%. And then you could walk up and down the two hillsides, and a lot of artists did it, and you could notice which plants were dying because of the lack of rain and make paintings of dying plants. And here I am 30 years later, remembering that aha moment where climate change happens at all scales, and some plants are happy and some are not. Thank you.
One thing that I wanted to mention about the changing landscape is I think I remember attending the QIP at Caltech like maybe 3 years ago. I can't remember exactly, can't keep the years straight, but Hopkins gave the dinner talk, the conference dinner talk on, how do people, asking the audience whether they prefer to do quantum information 20 or 30, 20 something, 30 years ago, or do they prefer to do it nowadays? And in the old time, it was much more, easier to do groundbreaking things, easier to do new things, and fewer papers to read. And nowadays, it's like you have tons of paper coming out every day, and it's much harder to do new and groundbreaking or unique things now. So that's something. I remember my answer. I mean, if I were to choose, is I may prefer. Well, maybe in between is a good, but but if I have to choose, it would be the older time where It's easier to do something original, or like it's everything you do is going to be original instead of stepping on some falling on somebody else's footsteps, but which is fine too. Anyway, but so it's so much going on now that it's hard to keep up in terms of how it affects my journey. And it's hard to feel unique as much, as an artist and some musician. It's nice to sometimes you want the quality, you're making a unique contribution, and it's a little bit harder to fulfill that, because anything you decide to go into, many people are thinking about that problem or working on something related. So anyway, so thanks.
We can move on to, let's do maybe one more question and then we'll move into some of the Q&A from the audience, I think. Um, so the one I'll finish out with here from this list is, from your experience, what distinct value do artists bring to engaging with particle physics? Is it just about public communication, or is there something more?
Okay, I'll have a go. I think artists bring really unique perspectives that can help scientists as well as public understanding. And I know Roger will have a lot more to say on this, but maybe not in the way that most people assume. The value isn't artists making science more accessible, but artists bringing fundamentally different methodological approaches to the same phenomena that scientists study. So like in Broken Symmetries, the exhibition that I was talking about that came out of the whole Arts at CERN visual arts program, the artists weren't trying to explain particle physics. They were using artistic methodologies to investigate those same phenomena. And I think it's interesting that when we worked on Broken Symmetries, they were dealing with this phenomena that fundamentally resists visualization, and that, as in any politics of representation, creates a choice. So do we use familiar but potentially very misleading imagery of particles as billiard balls and waves as water ripples, or do we push the audiences towards more abstract representations that might be truer to physics but less accessible? And I feel this dilemma is represented today in the easy grasp of easy concepts and easy representations that are misleading versus more nuanced ideas that are so essential to understanding society, not just understanding science and where it comes from. So our aesthetic choices become epistemological choices. They really determine what we know and what we can know. So the value is I think bringing artistic ways of knowing into the scientific process itself, which requires a kind of sustained institutional partnership and a lot of bravery to be able to do that.
Okay, since Nicola mentioned my name, I'm going to jump onto her use of the word concept. So what she's talking about is, in the technical language, is called concept transfer. Sometimes to solve a difficult problem in quantum mechanics, you cannot just use physics. You have to find a concept in some other area that might help you solve the difficult problem. And there's a huge literature on concept transfer as a research methodology. But just to finish, one of the people I spent a lot of time with is a stupid Italian mathematician called Michel Emmer. And he published an article in Leonardo on the mathematics of bubbles. And in one paragraph, he said, "Did you know in the world of bubbles, 1 + 1 does not equal 2. When two bubbles hit each other, they pop and 1 + 1 = 0. or two bubbles hit each other and one of them splits into two and 1 + 1 = 3. And then, I mean, what? So there's a concept to transfer, which is very appropriate for mechanics, quantum mechanics. So I'll just stop there, but just think about the mathematics of bubbles. Thank you.
I guess so. This question, if we can apply to any scientific discipline, I guess, as people have been doing, and I think that engaging with art, especially in a creative way, can really help scientists think about projects and their subjects and research in a different way sometimes. Uh, you know, I mean, of course, something to be studied, understood, how exactly shifts their understanding, just putting them in the driver's seat to be a creative partner beyond what they write, I think can really further their understanding or further or deepen in a different way, just in a different way. They try to look at it differently, narrate differently, how do they interact with music. It depends on the individual, how they take to it and what they get out of it, of course. But I'm hoping that this is a direction that can spark creativity as not just to help with scientific communications.
Yeah, if I can add something to this, I think it gets even deeper in my perception of it, in the sense that all like whether it's art or science or any field, really, anything we've built as a species to explain where we come from in the world around us and everything. It all starts with imagination, and I think everything is all a construction of the mind, of representation of what this or that might look like, whether it's a law that governs some aspect of nature, or whether it's an emotion that we want try to picture, or anything human or human related. I think stems from the same root of us trying to make sense of an experience and visualizing it in different ways or embodying it in different ways. So I mean, to me, there is just a big merger from the start between all disciplines, and so I'm not thinking of arts as being, art trying to bring visualization or communication to science, or science trying to draw things from art. I think for me, it really can coexist, and science is a form of art as well. And so, yeah, so it's just this deeper correlation for me, and using arts to try to bridge abstract imagination that stems from math or constructions that feel very, kind of up in the mind, to something that can touch the senses, whether that's performance or other ways of translating it. And there are all sorts of different ways to do that. And I think, I mean, in my case, when we did the quantum circus, it was all about using also interaction and drawing people in and trying to see how we could change the paradigm just for a moment of what people would see and what they would think and experience in the moment that would be different from the life they experience in the rest of their human experience, to try to spark some of that creativity and imagination in it, like in people, instead of trying to impose it from the outside.
That's beautiful. I think for me, the biggest thing that we gain from engaging, artistically with things like particle physics, what we can, the biggest thing I think for me is this idea of our fundamental idea of reality and how we perceive it, and what the tools we have within our bodies to perceive that are deeply flawed and fallible. And I know that's a very old idea, but I think needs to be more present than ever, given the current political climate that we're in. And there's something, there are so many wonderful, wonderful things that challenge our notion of reality, and the potential multiplicity of reality, or even fundamental unreality as an idea, that emerge from physics, quantum in particular, that I think are incredibly useful and incredibly beautiful and inspiring and humbling, and can be great forces and catalysts for change in how we see ourselves, how we see our identity, how we relate to each other. Even, you know, thinking about what you'd said there about the comic about racism disappearing at the quantum scale, Roger. It makes me think of that. You know, that actually there's a lot that we can gain from engaging with these things. And I also really agree that art and science are in so many ways one in the same, or intrinsically bound together, because they're part of our desire, I suppose, to understand ourselves, and understand ourselves in relation to each other, in relation to the universe that we are part of.
Great. Yeah. So the last few questions that we'll finish up here with are from the audience. So we may not be able to get to all of them. You're welcome to continue putting them in the chat. And it's possible that we can follow up later. But let's start out with this question, which may be directed to Camille, which is, how can the circus arts be used to convey quantum concepts? But also, obviously, anyone can jump in as well if you'd like.
So in our case, I mean, I've tried to link it to what I was trying to explain just before. There was an element of immersion. So there was this idea that, you know, trying to trigger interaction with the audience through the performing arts and trying to draw them in. So doing also, including interaction in the act itself, by having basically causality events, or like in a intuitive way happening between the stage and the audience, such as, for example, you know, pinning down some events that would happen on stage and then resulting in some events happening in the crowd by, you know, people who would be just you know, briefed within the crowd to like, for example, you know, throw objects or make some noises or whatever, related to different things that would happen on stage. That was one way to trigger that interaction and induce questioning, or like draw people into thinking causality and why things were happening, and try to find patterns and understand when they were happening. That was one way. The other way was to use movement, and to use, so in this case, that was aerials, so circus aerials, to use that the 3D movement in the air, because you're not bound to the ground or anything when you're doing circus aerials, to visualize some of the mathematical objects, such as, you know, what we call the block sphere, that represent spin states in mathematics and things like that, that are very, you know, it's usually like a sphere in vacuum kind of thing. And so when you have the ability to do something in the air, you can try to metabolize these very abstract mathematical objects into something that is embodied. So that was interesting for us. And then I think, yeah, the role play. So there was a lot of clowning too in our act, as part of the, you know, circus, clowning and juggling, because same thing, you want to really spark that curiosity of, okay, now this world is a different world, and, you know, and as part of the clowning act, you can be like, well, you know, things won't necessarily make sense. I mean, they kind of make sense in a different reality, which is the quantum reality in this case. They won't make sense right now, but yeah, it kind of gets people engaged and trying to think differently and see things differently. So that's how we did it. So we used visualization and all sorts of tricks to get people to just move out of reality for a moment, or at least their reality for a moment, and tune into a different one.
Thank you. So another question from the audience. So I know some of you have brought up a few different really cool resources as you've given your answers, but there's a question about some places that you would each recommend to look for further immersion with quantum and arts, such as books or films or lectures or things like this. So if any of you have any suggestions, that'd be great.
Okay, so I have a quick answer. If you ever can see some of the work by Krista Summerer and Laurent Mignonneau, you should try it. They have a famous installation called Nanoscale. Anyway, Krista Summerer, Laurent Mignonneau. And basically, they put a glove on your hands without telling you with magnets in them. And then there was a blue cloth on the table, and you put your hands on it, and they said, "Can you feel the atoms and molecules?" Well, in my head, atoms and molecules were round balls with different colors with wooden sticks between them. That's how stupid nanoscientists portray atoms and molecules. Well, no. I pushed my finger down on the table and it went through the atom. What? Atoms don't have edges? So yes, I recommend the work of Krista Summerer and Laurent Mignonneau that make you, and this is obviously tactile art, where you suddenly can understand things that you can't see or hear. What is really the shape of an atom and a molecule? And I could go on because here I am with my mind still thinking differently because of that artwork. Thank you.
That's so cool. I just shared a couple of links in the chat. So one of them that was just the title of this book again for anyone interested in exploring music and sound with quantum. There's a lot of good resources in there, and there's a second volume out now as well. And I also just shared Quantum site because they have a lot of applications that you can access open source as well. So, and again, you can find bits of code as well that you can use. There are really cool things that are free to use there as well that you can access. And I also put a resource to the Infinite Radio that we made together as well, so you can kind of hear that in action and see what that's all about.
I've put a quick link in the Q&A to a little publication that I edited a few years ago, which just introduces a whole group of different artists engaging with fundamental physics, as well as some physicists talking from their own human experience about their science. So a scientist who is also a wonderful dancer expressing it in that way, and another scientist who's interested in origami talking about how those folding techniques have helped him to understand cosmology. So it's just kind of a nice, easy intro, I think.
So I think unless anyone has any other last few resources they want to mention, I think that's all that we have time for, and we're at about the 12:15 Eastern mark. So thank you again for everybody's questions in the Q&A. So Stephanie put a comment in the chat. So if we didn't get to your question, we can still take them and send them to the right experts here on our panel. And so, yeah, thank you all for joining us in the audience and for your thoughtful questions. And thanks again to all of our panelists. This was a very interesting and fun discussion. I hope everyone was able to benefit from these insights and learn something about the intersection of quantum and arts here. So thank you again.